flaps extend downward into the flow of air beneath the wings to increase both lift and drag. They permit slower air speeds and steeper angle of descent during landing and approach. They also use them for slow flight. Trim, small adjustable hinge on surface on the aileron, rudder, and or elevator control surfaces. They are labor-saving devices that enable a pilot to release control pressure. Poor man's autopilot. PHAC 602 or 6-2. Describe the braking system on this aircraft. Refer to your POH, standard training aircraft. Hydraulically actuated disc type brakes are used on each main gear wheel. A hydraulic line connects each brake to a master cylinder located on each pilot's rudder pedals. By applying pressure to the top of either the pilot's or the co-pilot's set of rudders pedals, the brakes may be applied. PHAC 7-34. How is steering accomplished on the ground? Airplanes are generally provided with a nose wheel steering through mechanical linkage connected to the rudder pedals. PHAC 7-34. Except for the Grumman. What type of engine does your aircraft have? Mine has an O200 Continental, 200 displacement, horizontally opposed, 4 cylinders, 8 spark plugs. Refer to your POH 150 O200 Continental, 172 O360 Lycoming, O meaning carbureted, IO meaning fuel injected, 4-cylinder, horizontally opposed, direct drive, overhead valve, air-cooled, carbureted engine, which produces in the C150 105 horsepower, in the 172 180 horsepower at 2,700 RPM. PHAC 7-2. How does the carburetor heat system work? Carburetor heat allows unfiltered heated air from the shroud located around an exhaust manifold directed to the induction air manifold. Carburetor heat should be used anytime suspected or known carb icing conditions exist. What change occurs to the air-fuel mixture when applying carburetor heat? Warm air is less dense, so there is less air per unit fuel, causing the fuel-air mixture to become enriched. This causes a decrease in power. If ice is present, the melting ice will further contribute to temporary decrease in power, but do not turn carb heat off until the ice has melted. The U.S. We're just studying for a private pilot check ride. What four strokes must occur in a 4-stroke engine for it to produce power? Intake. The intake valve opens and the air-fuel mixture is drawn into the cylinders. Compression. The intake valve closes and the piston starts to moving to the top of the cylinder, compressing the air-fuel mixture. Power combustion. The fuel-air mixture is ignited, pushing the piston down. Exhaust. The exhaust valve opens and to clear the cylinders of burned gases. Suck, squeeze, bang, blow. PHAC 7-3. How's it going? What purpose do fuel tank vents have? As fuel level decreases, the space created must be filled with air so as to not create a vacuum. Fuel system vents provide a way for air to replace the fuel which has been burned. What type of fuel does your aircraft require? Minimum octane rating and color. 100 low lead, blue in color. Uh, you can't get a special thing from the FAA to allow you to use um, MoGas in 150, but A&Ps aren't a fan of that. Describe the electrical system of your aircraft. Refer to your POH. On a typical training aircraft, electrical energy is provided by a 28-volt direct current system powered by an engine-driven 60-amp alternator and a 24-volt battery. What does the ammeter indicate, and why is the generator alternator voltage output slightly higher than the battery output? Okay. The ammeter indicates charge-discharge rate of the battery. The difference in the voltage keeps the battery charged. PHAC 7-31. What are the 5 basic functions of aircraft engine oil? Lubricates the engine's moving parts, cools the engine by reducing friction, removes heat from the cylinders, provides a seal between the cylinder walls and piston, carries off metal, carbon particulates, and other oil contaminants. What conditions are favorable for carb icing? Temps below 70 degrees Fahrenheit and relative humidity above 80%. However, it can occur with temps as high as 100 degrees Fahrenheit and humidity as low as 50 degrees or 50%. Temps below 70 degrees Fahrenheit and relative humidity above 80%. However, it can occur with temps as high as 100 degrees Fahrenheit and humidity as low as 50%. PHAC 710. Define the terms anti-icing equipment, de-icing equipment. If your aircraft has this equipment, can it be flown into icing conditions? Anti-icing equipment prevents ice from forming. Ergo, heated pitot tubes, static ports, and carb heat. De-icing equipment removes the ice was already formed on protected surfaces. Ergo, boots. The POH will state whether the airplane is approved for flight into known icing conditions, FIKI, and list any associated limitations. Don't do that with training aircraft. What is detonation? Detonation is an uncontrolled explosive ignition of fuel-air mixture in the cylinder's combustion chamber. It leads to excessive temperature and pressure, which can lead to failure of the piston cylinders or valves. The first sign of detonation are engines overheating, roughness, or loss of power. LOP. What are some of the most common causes of detonation? Using lower fuel grade than that specified by the aircraft or engine manufacturer, operating the engine at high power settings and with an excessively lean mixture, extend ground operations, or steep climb where cylinders cooling is reduced. What action should be taken if detonation is suspected? used in rich fuel mixture as well as a shallow climb angle cruise climb to increase cylinder cooling during takeoff and climb. Avoid extended high power steep climbs. Monitor the engine instruments to verify proper indications. What is pre-ignition and what actions can be taken if it is expected? Occurs when the air fuel mixture ignites prior to the engine normal ignition, engine's normal ignition. Occurs when the air fuel mixture ignites prior to the engine's normal ignition. Usually caused by residual hot spot in the combustion chamber. This can quickly destroy the engine. So what should you do? Reduce power, reduce climb rate, reduce climb rate, enrich air fuel mixture, and open cowl flaps if equipped. These all reduce the temperature inside the cylinders, which can help stop pre-ignition. PHAC 719. What instruments operate off the pedostatic system? That is the airspeed indicator, altimeter, and vertical speed indicator. AA V. Airspeed indicator, altimeter, vertical speed indicator. What does a mechanical altimeter, or how does a mechanical altimeter work? Aneroid wafers expand and contract as atmospheric pressure changes. Through shaft and gear linkages, pointers on the altimeter rotate. PHAC 8-3. What are the limitations of the pressure altimeter? On warm days, the altimeter shows a lower altitude than actual due to higher pressure levels. On cold days, it shows a higher altitude due to lower pressure levels. Always remember, high to low, look out below. No, redo that one. On warm days, the altimeter will show a lower altitude than actual due to higher pressure levels. On cold days, it shows a higher altitude due to lower pressure levels. Always remember, high to low, look out below. How does the airspeed indicator operate? It measures the difference between the ram air pressure from the pitot tube and static pressure from the static source, which is translated to a reading on the airspeed indicator through mechanical linkages. PHEC 8-8. What is the limitations of the airspeed indicator? Airspeed indicator is subject to proper flow of air through the pitot-static system. PHEC 8-8. What are the errors of the airspeed indicator? Position error. This error occurs when the static port senses incorrect static pressure due to disturbance caused by slipstream flow. Compressibility error. At high air speeds, air packing into the pitot tube causes this error, leading to higher than normal indication. It is generally not a concern in training aircraft. Okay. What are the different types of aircraft speeds? You have indicated airspeed, the airspeed that reads directly from the airspeed indicator. Calibrated airspeed, the indicated airspeed adjusted for position and instrument errors. Equivalent airspeed, the calibrated airspeed corrected for compressibility. True airspeed, calibrated airspeed representing the actual speed of the airplane relative to the air mass in which it is flying. And then you also have ground track. What airspeed limitations apply to the color-coded marking systems on the airspeed indicator? The white arc, flaps operating range, lower airspeed limit, white arc, VSO, stall speed in the landing configuration, upper airspeed limit of the white arc. Okay, redo this. Okay, the white arc is the flaps operating range. Lower airspeed limit of the white arc is VSO. Stall speed in the landing configuration. The upper airspeed limit of the white arc is VFE, the maximum flap extended speed. Green arc is normal operating range. Lower airspeed limit of the green arc is VS1. Stall speed in the clean or specified configuration. Yellow arc, recommended for operation in smooth air only. Red line is VNE, the never exceed speed, above which structural failure may occur. How does the vertical speed indicator VSI work? VSI uses two aneroid capsules, one having a calibrated leak. Since the calibrated leak let air out of slowly, it creates a pressure differential. The diaphragm is squeezed, moving the gears which are connected to the VSI needle. Okay, we're going to do this again. The VSI uses two aneroid capsules, one having a calibrated leak. Since the calibrated leak lets air out slowly, it creates a pressure differential. The diaphragm is squeezed, moving gears which are connected to the VSI needle. What are the limitations of the VSI? The vertical speed indicator is not accurate until the aircraft stabilizes, typically taking 6 to 9 seconds. Sudden or abrupt changes in aircraft attitude can cause erroneous readings due to fluctuating airflow over the static port. Both rough controls techniques and turbulent air can result in unreliable needle indications. What are the gyroscopic instruments? Attitude indicator, heading indicator, turn coordinator. What are the two fundamental properties of a gyroscope? Rigidity in space, the principle that gyroscopes remain fixed position in the plane in which it is spinning. Precession, the tilting or turning of the gyro in response to deflective force. The reaction to this force does not occur at the point that is 90 degrees later. It reacts 90 degrees later in the direction of rotation. So gyroscopes the reaction of this force does not occur at that point. The reaction occurs 90 degrees later in the direction of rotation. PHAC 8-15. What are the power sources that may be used to power the gyroscopic instruments? The vacuum system uses a pump to create suction that spins the gyros. Commonly powers the attitude indicator and heading indicator. Electrical system uses electrical motors to drive the gyros. This is the most common source for the turn coordinators. How does the attitude indicator work? An attitude indicator works by using a gyroscope to maintain a stable reference to the horizon. When the airplane pitches and rolls, it rotates around the gyroscope, and the difference between the airplane and the gyroscope rigid position is displayed as pitch and bank angles on the instrument. What are the errors associated with an attitude indicator? Precession error. When an external force causes the gyro to tilt, it responds at a point 90 degrees later than the direction of rotation. Acceleration error. Rapid acceleration or deceleration can cause gyroscopic instruments to show false readings, particularly during takeoff. What does the heading indicator operate and what are its limitations? The rotor turn in a vertical plane and the compass card is fixed to the rotor. Since the rotor remains rigid in space, the points on the card hold the same position in space relative to the vertical plane. As the airplane revolves around the card, as the airplane revolves, the card provides clear and accurate heading info. Heading indicators are typically limited to pitch or bank angle of no more than 55 degrees. Beyond that, the instrument will tumble, requiring reset. PHAC 8-20. I'm going to redo that one. How does the heading indicator operate and what are its limitations? The rotor turns in a vertical plane and the compass card is fixed to the rotor. Since the rotor remains in rigid space, the points on the card hold the same position in space relative to the vertical plane. As the airplane revolves, The card provides clear and accurate heading information. Heading indicators are typically limited to pitch or bank angle of no more than 55 degrees. Beyond that, the instrument will tumble, requiring reset. PHAC 8-20. What error is the heading indicator subject to? The heading indicator is prone to precession or drifting from the set heading, showing up to 15 degrees of drift per hour of operation. To correct this error by using a knob rotating Pilots correct this error by using a knob to rotate the heading indicator to match the magnetic compass. 8-20. The heading indicator is prone to precession or drifting from the set heading, showing up to 15 degrees of drift per hour of operation. Pilots correct this error by using a knob to rotate the heading indication to match the magnetic compass. Okay. How does the turn coordinator operate? Turn coordinator uses gyroscopic mechanism mounted at an angle to detect and indicate the rate and direction of an aircraft's turns by sensing both roll and yaw. The gyroscope maintains a fixed operation or orientation. The gyroscope maintains a fixed orientation in space, and the instrument displays turn rate through the precession effects as the aircraft turns. What will the turn indicator indicate when the aircraft is in a skidding or slipping turn? In a skidding turn, the turn coordinator ball moves towards the outside of the turn. In a slipping turn, it moves toward the inside. PHAC 8-18. How does magnetic compass work? Magnetic compass works by aligning a magnetized needle with the Earth's magnetic field. This alignment indicates the aircraft's heading relative to magnetic north. PHAC 8-23. What are the different classes of airspace in the NAS? Classes of airspace include Class A, B, C, D, E, and Gulf, each with specific operating rules and requirements. PHAC 15-8. What errors is in the magnetic compass subject to? What error is the magnetic compass subject to? Deviation. This error is caused by the presence of magnetic material or electronic currents within the aircraft. Variation refers to the angular difference between true and magnetic north. Acceleration and deceleration errors. During changes in airspeed, the compass needle can temporarily indicate incorrect headings due to forces acting on the compass card. PHAC 8-26. Describe the instruments associated with an electrical flight instrument display. Attitude and heading reference system provides attitude and heading info using sensors such as accelerometers and ring laser gyroscopes. Air data computer, which processes data from the pedostatic system and determines airspeed, altitude, and vertical speed. The primary flight display presents attitude, airspeed, and heading. Multi-function display offers navigational charts, weather, radar, traffic, engine data. Flight detector provides guidance cues to assist in flying specific flight paths, either to hand flying pilot or the autopilot. What display info will be affected when an ADC failure occurs? ADC failure can lead to unreliable airspeed, altitude, and vertical speed indications. Often a red X will be placed over the affected instrument to tell the pilot there is a failure. PHAC 8-14. What is the purpose of the National Airspace System, NAS? National Airspace System is a network of airspace, air traffic control facilities, and navigational aids designed to ensure safe and efficient air transportation in the United States. PHAC 15-7. What is Class A airspace? Class A airspace is used for high altitude en route air traffic, requires pilots to operate under Instrument Flight Rules IFR and maintain clearance from air traffic control and obtain clearance from air traffic control. It exists from 18,000 feet MSL up to and including flight level 600, 60,000 feet. PHAC 15-9. Remember to say that one. Class A airspace is used for high altitude en route air traffic and requires pilots to operate under Instrument Flight Rules IFR and obtain clearance from air traffic control. It exists from 18,000 feet MSL up to and including flight level 600, 60,000 feet. PHAC 15-9. Above that is Class E again. Describe Class B airspace. Class B airspace surrounds the nation's busiest airports and requires pilots to obtain a clearance from air traffic control to enter. It is designed to ensure safe operations of aircraft in congested areas, depicted as solid blue lines on a sectional chart, like an upside-down wedding cake. You need to hear cleared into Class Bravo, or cleared into the Bravo. Your tail number and cleared into the Bravo, since it's Class Bravo. What is Class C Charlie airspace? Class C airspace is typically established around medium-sized airports. Requirements for entry: two-way radio communication, a transponder with altitude reporting, and a DSB out. It typically extends from the surface to 4,000 feet AGL, depicted as solid magenta lines on a sectional chart. Smaller magenta wedding cake upside down, or solid magenta upside down wedding cake. You need to hear your tail number when you have two-way comms. Describe Class D airspace. Class D or Delta airspace is established around smaller tower airports, requires two-way radio communication for entry. Unlike Class C, a transponder is not required, depicted as blue lines on a sectional chart. Blue dash line. What is Class E airspace? Echo. Class E or Echo airspace encompasses controlled airspace not classified as Class A, B, C, or D, and can extend from the surface up to, but not including, 18,000 feet MSL. Surface area Class E is depicted as dashed magenta lines on sectional charts. 14 CFR Part 91.155. Describe Class G airspace. Class G, or Gulf airspace, is uncontrolled airspace that exists below Class E airspace, extending from the surface to the base of the overlying Class E airspace, which is typically 1,200 feet AGL unless depicted otherwise. PHAC 1510. Describe the purpose of a terminal radar service area, TERSA. TERSA, terminal radar service area, are airspace areas surrounding certain Class D airports where radar service is provided to participating VFR aircraft. Depicted as solid gray lines on a sectional chart, TERSAs can be thought of as optional Class C airspace. PHAC 15-7. What is a temporary flight restriction? TFR, temporary flight restriction. A temporary flight restriction, or TFR, is a temporary restriction of flight operations in a particular area due to hazardous conditions, special events, or VIP movements. PHAC 15-6. What are the different types of special use airspace? Different types include prohibited areas, restricted areas, warning areas, military operation areas, MOAs, alert areas, national security areas, and controlled firing areas. Describe a prohibited area. Prohibited areas are established for security reasons and prohibit flight by civil aircraft. Violations of prohibited areas can result in interception. What is a restricted area? Restricted area contains airspace where flight operations are subject to restrictions due to hazards such as artillery fire and aerial gunnery. You can enter in if they're active and you request entry, but you should just go around them. What is the purpose of warning areas? Warning areas airspace extending from 3 nautical mile outward from the coast of the United States that contains activity which may be hazardous to non-participating aircraft. What are military operation areas, MOAs? Military operation areas, MOA, is airspace established to separate military training activities from IFR traffic. VFR traffic may enter on active MOA without clearance, but this is ill-advised. If flying through an active MOA, use extreme cautions. Flight following is recommended. Describe alert areas. An alert area is airspace where there is a high volume of pilot training or unusual aerial activity marked on a chart to inform non-participating pilots. What is a controlled firing area? A controlled firing area are areas where military activities are conducted, includes live ammunition firing. Activities are suspended immediately when non-participating aircraft approach. What does the term VFR corridor refer to? A VFR corridor is a designated airspace route through Class B airspace where VFR aircraft can operate without an ATC clearance, but with specific altitude and route restrictions. What is the minimum visibility and distance from clouds required for VFR flight in Class Golf airspace below 1,200 feet AGL during the day? Class Golf during the day. Minimum visibility is 1 statute mile. The aircraft must remain clear of clouds. 1 statute mile, clear of clouds. What are the weather minimums for flying VFR in Class Golf airspace at night below 1,200 feet AGL? 3 statute miles, 152, 1,000 feet above, 500 feet below, 2,000 feet from clouds. 3152, Golf at night. What are the weather minimums for flying VFR in Class Echo airspace at above 10,000 feet MSL? 5 statute miles, 1,000 feet above, 1,000 feet below, and 1 nautical mile horizontal distance from clouds. What are the weather minimums for flying VFR in Class Echo airspace below 10,000 feet MSL? 3 statute miles of visibility, 152, 1,000 feet above, 500 feet below, 2,000 feet from horizontal from clouds. What are the weather minimums for VFR in Class D airspace, Class Delta? 3152, 3 miles of visibility, 1,000 feet above, 500 feet below, and 2,000 feet horizontal distance from clouds. What are the weather minimums for flying VFR in Class C Charlie airspace? 3152, 3 statute miles, 1,000 feet above, 500 feet below, 2,000 feet horizontal from clouds. What are the weather minimums for flying VFR in Class Bravo airspace? 3 statute miles of visibility, clear of clouds. Can VFR fly in Class A Alpha airspace? No. What does Mode C veil refer to? The airspace within 30 nautical miles of a Class Bravo airport where an aircraft must have an operating Mode C transponder and Aegis B out. How often do VFR sectional charts expire? Every 56 days. What are VFR weather minimums for airport with overlying controlled airspace, Bravo, Charlie, Delta, Echo? What about overlying uncontrolled airspace? Controlled is 3 statute miles, ground visibility, 1,000 foot ceiling. Uncontrolled, 1 statute mile, ground visibility, clear of clouds, day. What are the requirements for special VFR? What about special VFR at night? Special VFR allows pilots to operate in controlled airspace with less than standard VFR minimums. You must obtain a special VFR clearance from the controlling ATC facility, have 1 statute mile visibility, and remain clear of clouds. At night, pilots who are instrument rated and in instrument equipped aircraft can request SVFR, so you need to be IFR. 14 CFR Part 91.157. Can you request SVFR in any controlled airspace? SVFR can only be conducted in controlled airspace around an airport. That's Bravo, Charlie, Delta, or Echo service areas. 14 CFR, Part 91.157. What are the 4 types of NOTAMs? A distance or NOTAM, parentheses, delta, domestic, I apologize, starting on that one over. Domestic or NOTAM D, Flight Data Center, FDC NOTAMs, Special Activity Airspace NOTAMs, SAA NOTAMs, military NOTAMs. What are the primary components of the aircraft traffic pattern? Upwind departure leg, crosswind leg, downwind leg, base leg, final. PHAC 8-1. What is the standard altitude for a traffic pattern at most airports? What is the direction of turns unless otherwise specified? 1,000 feet AGL for a single engine piston aircraft and left-hand turns. PHAC 8-1. What should a pilot do when approaching an uncontrolled airport? What are the standard entry and exit procedures for traffic patterns? Announce their position and intentions on the Common Traffic Advisory Frequency, the CTAF. Enter the traffic pattern at a 45-degree angle to the downwind leg, or exit straight out, or at a 45-degree angle to the left when in left-hand traffic pattern. PHAC 8-4. What is a calm wind runway? A runway designated for use when wind conditions calm or light and variable, typically less than 5 knots. PHAC 13-13. So a runway that you can't use unless it's calm wind. What is a go-around and when should it be executed? A go-arounds are initiated if the pilot or controller is not completely satisfied that the requirements for a safe landing are in place. For example, a go-around would be initiated by the pilot or controller when the approach becomes unstable, another aircraft is on the runway, or there are other safety concerns. PHAC 8-6. What is the purpose of a cleared or the option clearance from ATC? It allows the pilot to perform a touch and go, stop and go, low approach, miss approach, or full stop landing. Airman Flying Handbook 9-6. What are the key elements of pre-takeoff briefings? Departure runway, initial heading, assigned altitude, emergency procedures, and any special instructions. Airman's Flying Handbook 2-22. I'll redo that one. What are the key elements of a pre-takeoff briefing? What are the key elements of a pre-takeoff briefing? Departure runway, initial heading, assigned altitude, emergency procedures, and any special instructions. Airman Flying Handbook 2-22. Flying Handbook. What are hotspots on an airport diagram? Locations on airport surface with a history of runway incursions or points of confusion. PHAC 8-14. How should a pilot determine the active runway at a non-towered airport? By observing the windsock, wind T, or segmented circle, and by listening to traffic on CTAF. PHAC 14-20. What is a NOTAM and why is it important? A NOTAM, or Notice to Air Missions, provides critical information about airport conditions such as runway closures or obstacles that are not published on charts. PHAC 14-4. What are the key components of an airport surface markings? Runway markings, taxiway markings, hold position markings, and signs. PHAC 14-7. What does a hold short line indicate? A mandatory stop point prior to runway that an aircraft must have clearance to cross, either through crossing clearance or other instructions to enter the runway. Looks like that. What are the various runway markings? So you have the threshold line, the bunch of dashed lines at the beginning. You have the whole short line. You have the touchdown markers or captain's bars, typically around 500 feet. And then you have the aiming point or 1,000 footers. What are runway incursions and what are the primary cause? A runway incursion is an unauthorized presence on a runway, often caused by a pilot or vehicle operator error, miscommunication, or confusion. PHAC 14-31. What is an ATIS broadcast? What information does it provide? An automatic terminal information service, ATIS, provides recorded information on current weather, runway in use, and operational details. PHAC 14-5. How should a pilot execute a proper runway crossing? Obtain clearance from ATC if at a towered airport. Visually clear the area at towered and non-towered airports before proceeding. Verify that the runway number in the clearance matches the one you are about to cross. Turn on all exterior aircraft lighting. What should a pilot do if they become lost on the airport surface? What should a pilot do if they become lost on the airport surface? Stop the aircraft, ask ATC for help, or use airport signs, markings to reorient. Plan and brief your expected taxi route using an airport diagram prior to commencing taxiing. PHAC 14-33. What are the colors of airport beacons? Civilian airports, white and green. Seaports, white and yellow. Heliports, green, yellow, white. Military airports, 2 white, 1 green. What do the various ATC light gun signals mean? PHAC 14-25. Okay. So you have this huge chart. Alright, so color and type of signal for steady green in the movement, vehicle, equipment, and people. Clear to cross, proceed, or go. Aircraft on the ground, cleared to take off. Aircraft in flight, cleared to land. Flashing green, the movement of vehicle, equipment, and people, not applicable. Aircraft on ground, cleared to taxi. Cleared to taxi. Aircraft in flight, return for landing. Steady red for movement, vehicle, equipment, and people, stop. Aircraft on the ground, stop. Aircraft in flight, give way, continue circling. Flashing red, clear the area. Aircraft on the ground, taxi clear the runway. Aircraft in flight, aircraft in flight. Airport unsafe, do not land. flashing white, moving a vehicle, equipment, and people, return to the starting point. Aircraft on the ground, returning to your starting point. Aircraft in flight, not applicable. Alternating red and green for all categories, use extreme caution. What is the purpose of a clearance delivery frequency? Clearance delivery frequency. To provide pilots with their IFR VFR clearance before taxiing. PHAC 1617. What does the acronym LASSO stand for? LASSO or land and hold short operations. When an aircraft is instructed by a controller to hold short of an intersecting runway, taxiway, or a designated hold short point, student pilots should not participate in LASSO land and short position operations. What are the colors of runway edge lights, and what are the color of runway centerline lights? Edge lights are white, then yellow for the last 2,000 feet, or half the runway length, whichever is less. Centerline lights are white until the last 3,000 feet of the runway. The white lights begin to alternate with red for the next 2,000 feet. For the last 1,000 feet, the runway centerline lights are red. PHAC 14-17. Alright, we're going to call that today.